We don't want like in the vision, to have the patient in a lonely room just with a computer screen, but I believe, really this combination of a physician, with the support of powerful AI tools, that is the future for healthcare.
Welcome to a brand new episode of our podcast, Human and AI, Mind, Machines, and the Great in the Sand.
Thanks that you tuned in again to listen and to learn. We are Uli and Avery, and we can't wait to introduce you to the super charming genius mind, Tobias Heimann. Tobias is the head of artificial intelligence in Germany at Siemens Healthineers and has been working on automatic medical image understanding problems since the early 2000s. So today in this session, we want to dive in a little bit deeper to learn more about the impact of AI in health, what precision medicine is actually all about, and what the difference between Forchheim, which lies in Franconia, and Princeton in the US is. So we're super excited to have you here, Tobias. Thanks for joining this session. How are you, and where do we catch you today?
Yeah, hi. Thanks a lot for inviting me to this podcast. Very cool format. So, where am I? As usual, I'm in the home office for the past half year, more or less. So, sitting here at my desk, very good so far. I had the last couple of days off, so this is actually my first mission of the week.
Welcome back, Tobias.
Thank you.
The last time I remember, we were actually also the first time we met was in Vienna, right? You have this crazy world conference, radiology conference, right? And
ECR, yes.
ECR, right? And you have this lovely booth where you can experience digital twin and also, different deep learning demonstrators, right? And I thought, like, quite nice, right?
Yeah, that was cool.
Maybe for the audience out there, right? Can you guide us a bit around, who the heck are you and what the heck are you doing and how do you end up at a place like Siemens?
Okay, so that means we should start early, right? So let's see. I was born sometime end of the 70s in East Westphalia in northwestern Germany. Started programming as a teenager, basically back then on a 286 PC. I did some graphics, did some games programming. I was always fascinated by computers, so from the start, right? So when it came to selecting a field of studies, computer science was kind of the natural choice for me. The question was which application, because obviously you can use computer science for a lot of different fields. I was thinking a little bit and decided to pick medicine as field of application because I thought, well, there's always, right, with every technology, you can use it for good things, you can use it for maybe not so good things or questionable. And I thought medicine, that's the space where I can really do something for the greater good, right, so to speak. So I like the field and I like the idea of making contributions and helping other people with computers. So I started studying medical informatics in Heidelberg, in Heilbronn in the late 90s, focused on image signal processing. I loved research, right, from the start, so it was pretty obvious that I wanted to do a PhD. And I did that. I worked on automatic image analysis back then, medical 3D image already, using some statistical shape models. And I liked the field. I liked what I was doing. And I always had this plan to stay in research, right, and continue in academia. So I did like a couple of postdocs after my PhD. But I mean, in academia, it's kind of difficult to have a straight path, right, to kind of a professorship. So I was looking at different options, what I could do, and actually some people recommended me to have a kind of side track in industry, right, to gain some additional expertise and then maybe come back from there. So at that point, there was a position at Siemens Corporate Technology in Erlangen in automatic image analysis, which was a perfect fit to what I have been doing before. So I applied for that. I started with Siemens, and yeah, I kind of sticked, right? I never went back to academia.
So here you go, right?
Yeah, that's how
No,
I ended up in the company.
it's still no trades off to, it's like actually would be great to, join also academia back, or just leave the sports and say like actually you get all the degree of freedom in apply research. Is that sufficient enough?
Yeah, I mean, for me, it turns out that was sufficient enough. So what I found really strange, that when I joined Siemens Research, that I had the impression, that I could focus much more on my research than I was able in academia, because in the company we have things more organized. There are people who are doing research, there are people who are doing management, there are people who are doing, I don't know, contracts, everything, right? While in academia, you are supposed to do everything at once, and that leaves you less time, right, as a researcher, at least, to focus on research. That was my experience, at least. So I like this researcher position that I had at Siemens when I started.
What an exciting journey. So you're the head of artificial intelligence for Health and News in Germany. But where does your passion for AI actually come from? What fascinates you about artificial intelligence?
Good question. I mean, I always love to push the boundaries, right? It's like when I started working with computers and programming as a teenager, yeah, it was always so, wow, can a computer do this? Yeah. And when you ask that question, you almost inevitably you end up with AI, yeah, because for a computer to do certain things, it needs some, well, kind of intelligence in quotation marks, yeah, and you end up with these methods, machine learning, etc. So for me, AI is one of the most challenging and exciting fields, because you can really see what's possible.
And what's not possible, I guess, still, or maybe
As well.
aspiring to be possible.
Lots of things that are not possible as well. Yeah.
Speaking of crazy ideas, right? There's a lot of hype currently. I guess, right? Most recently was on the interfaces of technology interfacing, some kind of living beasts, or let's say pigs, right? I don't know. Do you follow up what Neuralink does, and do you have any opinion on that?
I have to admit, I follow up very loosely. I mean, I've read Neuromancer, and no question about possibilities about neural link interfaces, etc. Actually, I even consider that as a career, like as a research field for me, like 20 years back, when I had set on doing computer science in medicine. I was like, yeah, what could I do, right, in that space? And I love this idea of neural interfaces. But I think, I mean, with all the advances, that have been achieved in the past years, like if you think of, I don't know, neuroprosthetics, for example, there's a lot of stuff that is possible today, which, I don't know, 20, 30 years ago was still a bit like science fiction. So obviously there's a development there. But hey, like a computer interface like they envision is, I think it's still a long way to go, right? So not sure. I'm skeptical for now. I like to be surprised, but I think there's a lot of unsolved issues there.
Yeah, and I guess, right, putting a Raspberry Pi underneath the skull, right, that involves some kind of trust. And maybe pigs are very trustful. But speaking of trust, right, I've read a small sentence actually in you, right, that you reflected on the interfaces, human machines and machine learning. You stated like we have to make AI a very personal experience for patients, and one that inspires trust. So that's kind of interesting statement, right? Is a technology able, like ML or stuff like that, to inspire trust? Can you elaborate a bit? What do you mean with that?
Yeah, I mean, there was kind of a response if you talk to people, right, about AI, and I talk quite a bit to, I don't know, so our customers, for example, when they are visiting, and everybody's interested in AI. I mean, some people are really enthusiastic about it, but there are also many people who are critical. Yeah, and one aspect that's always coming up is this trust thing, right? So this is why I believe if we want to really push AI applications in healthcare and also in other fields, we need to answer this trust question. And like for me personally, how do you inspire trust, right? With technology. So I think number one, trust is inspired by performance. If you have system which really performs well and robust, then people will trust it over time. Yeah. At the beginning, of course, it's new, so there will be a certain hesitancy to pick it up. But over time, I think if you are able to deliver consistent performance, then people will trust the technology. That has happened in the past, right?
Reliability, basically.
Reliability,
right?
exactly,
Okay,
exactly.
okay.
Performance reliability. The second thing is transparency, yeah, which I believe is especially important for AI because it's not really a new topic, yeah, and there have been already so many movies and so many books about AI, more from the fiction side of it. But now that it's like moving into our reality, I think a lot of people are unsure what's really behind, right? And where's the connection between this AI that we see now in our daily lives and the AI that we read about maybe 20 years ago? So transparency, yeah. What is the technology that we use for AI? How does that work? How does machine learning work? What's behind? How do we make sure that the solutions work? How do we validate things? This also for me is a big part of the trust. And then finally, I think it's the explainability of the results. You have typically this black box problem, right? In AI, that you have a system that tells you maybe some answer or outlook or whatever, but that's it. You get one number, you get one result, and there's no way of questioning it. Now, there are, of course, a number of possibilities how you can do that. You can work on technology, that you can ask the system, hey, give me some explanation about how do you come to this conclusion. So this is one way. And I mean, another way is also that you explain the results by kind of mediator, in the case of healthcare, that would be the physician. The physician is using AI tools, gets the results from there, but due to his expertise, he's able to interpret that and can explain the results, the outcomes to the patient. And this is also what I meant with personal, right? So we don't want like in the vision to have the patient in a lonely room just with a computer screen, yeah. But it's, I believe, really this combination of a physician, yeah, with the support of powerful AI tools, that is the future for healthcare. And that setup, I think, will also inspire this trust. Yeah.
Wow, well put, I would say. So there must be so many awesome application areas for machine learning out there. So what are use cases, maybe externally, of AI in healthcare that really fascinates you?
Use cases, yeah, as you say, there are a lot, right? I mean, potentially in all the areas of healthcare and along the workflows, we could use AI technology to make things more accurate, more efficient, yeah, safer. I think for me personally, the most fascinating or most interesting use case is in diagnostics, right? Diagnostics and therapy decision. Because if you look at it, yeah, healthcare used to be quite static as a field, like in terms of knowledge, right? How knowledge was expanding, etc. We had, I mean, certain disciplines, like I give computer science, yeah, as an example. Computer science was always developing like super rapidly, yeah. So when you were studying computer science at university, the books that you had were a couple of years old, already outdated. Yeah. That was not the case with medicine. But medicine has also accelerated significantly, yeah, over the past years. And the amount of knowledge, of new knowledge that is generated in medicine is tremendous, right? So the question is, as a physician, I mean, you're doing your studies. Yeah, maybe while you are studying, if you're lucky, your books are not outdated yet. But then you start practicing, and what happens after 5 years, after 10 years, yeah, where you're gaining expertise? There's so many new results in research, so many new studies, etc. How can you keep track of that? I believe that is super challenging if you don't have any kind of support system for you. And for me, what I envision is you have this AI system as a support for the physician, yeah, that has all the latest medical knowledge fed in, so to speak, yeah, from studies, from research, etc., and can use that to really help the physician taking the right diagnosis and recommend the best therapy. So this is one aspect, I would say, yeah, with the rapidly advancing knowledge in medicine. The other aspect where I think AI could be like very helpful and very powerful is when it comes to expertise, for example, in radiological image interpretation. Yeah, maybe radiological image interpretation, I don't know, if you stick to a standard modality, there's maybe not so many changes over time, but the capability of a physician to read these images is in a large part is due to his experience. So how many images has the physician seen? How many patients has he treated, right? Here I just see the power, yeah, if we can train an AI system with hundreds of thousands of cases, radiology images, these are more than any physicians could see and read during his lifetime. And I believe this information that we can take from that, yeah, that it must be able to harness that somehow in taking better decisions and better readings also from radiology images.
Right. We are also super interested at is learning more about the groundbreaking use case of the digital patient twin that you were working at the Siemens Health News.
Mm-hmm.
So is that something like in the future, will we eventually look in the mirror in the morning and see ourselves in a digital version with all information at hand, ranging from, I don't know, the pulse over the carbon and energy footprints to finally predictive measures and actions? Will that be the digital twin of the future? And how do you envision healthcare to be in the long-term future, and the role of AI? Will it be like human and machine interaction, like you already like indicated right now, or is there more?
I think long-term future is the important keyword here that you mentioned, right? So yeah, in the long-term future, I could indeed envision a system like you described, right, where we have a digital twin of the entire patient, of the entire individual, right? For predicting basically the health. Are there any risks? Yeah, how could we prevent those, etc.? I mean, for now, what we are doing is we are focusing on, let's say, individual, let's say, organ digital twins, for example, right? So we have this work on the heart that you might have seen, right? Or other organs like from the liver that we are working on. So these are very concrete use cases, very concrete organs, very concrete therapies that we want to support with that. But the idea is basically the same, yeah, that we have a virtual representation of the specific organ or organ system, and we can basically virtually apply a certain therapy, and then the computer will give a prognosis about the effects of this intervention, right? So that is the main idea behind the digital twin. We have some very cool results, I think, for some of these organ models. Before we reach the state where we have like the whole patient models, etc., like you described, I think that will still be a number of years until we get there. Yeah.
But it means you simulate actions before you apply it to the actual real patient, right? This is the main aspect.
Right. That we are doing.
Nice.
For example, with the heart, we have this cardiac resynchronization therapy intervention, which is basically now you implant a pacemaker, and then the question is, where do you place the lead of the pacemaker on the heart, and how do you program it, etc., and what's the effect on the function of the heart? And this is something that we can already today, we can simulate this, right?
And what a huge impact that can have actually to the patient. Yeah, speaking of health, and we are all in a pandemic right now. COVID-19 is all around and everybody's facing it. So here's the question: how can AI and digital twin help us to address those challenges? Are there already any use cases out there?
There is indeed, I mean, at least one use case that I can tell you of that we are working on, which I believe is pretty cool, and that is also in the space of diagnostics of COVID-19, right? So early on in the pandemic, I would say, like, let's say March or something, when things really, when it became evident, that things would become serious, it was one of the big problems was like, how can you quickly diagnose people, right? Because tests were still to be developed at that time, but it took quite a long time until you would get the result of your tests, etc. So there's one question: how to test if somebody has COVID-19, but then also how to quickly evaluate the severity of the disease, which is especially important, I think, when we come to the situation that hospitals are operating at their limits, right? And maybe the spaces, the beds for the high intensity care unit get scarce, and you need to quickly decide when a new patient comes in, like, will this patient need special care? Will this patient need intensive care? Or could he maybe be released in 3 or 4 days, right? So we were looking into ways of what we could do to work in that space. And as you know, one of the organs that is most severely impacted, by COVID-19 is the lung. And it turns out that patients develop this kind of airspace opacities, in the lung that you can see on CT images, for example, right? So we started developing a prototype, then back in March, April, that from a chest CT image could automatically quantify these lesions in the lung and therefore give you some quantitative value of severity of the disease for a certain patient. And that is actually a product right now with our AI Red Companion chest CT module. I believe it's probably the fastest product that we ever developed at the company. Like, if you imagine that we started working on it, I don't know, in March or something, with data collection, etc. And now it's out and people can use it, and they are using it, like hundreds of installation. So I think that is pretty cool and a good example of what AI can do in that space.
Nice. That's pretty dope, actually. Pretty nice, pretty impactful, and pretty relevant, I guess, as well. Right? There's a lot of tools, obviously, currently data driven, right? AI seems to be also synonymous on ML like aspects, right? But I see already, right? I see the face already coming up again, right? The symbolic movements, right? I feel them already, right? On the first conference, I see them. Go away, you deep learning thing, right? What is your estimate? When will the ML community or AI community draw back again to the symbolic aspects like causality or expert systems? Do you think, the second wave is coming again?
For sure. For sure, sometime. But the question is when, right? I think people need to get really bored of deep learning first, And I mean, right now, if you look at the output, there's still always developments, in deep learning. Also, you have some nice new methods, I mean, maybe not revolutionary new changes, but always some changes here, some kind of new approach here and there that helps you to tweak your models, to maybe try some different architecture, etc. And the results are still improving if you look at the popular benchmarks, right? And I believe why results are still improving with deep learning, and while there are still new applications that can be solved with deep learning, probably the largest amount of people will stick with that and work with that. But when things will be, I don't know, I expect at a certain point things will probably slow down, right? And then will be the hour of the symbolic processors.
Yeah, but I mean, is there actually a specific certification process in the organization exist for deep learning, so machine learning or data driven, whether it's deep learning or traditionally machine learning aspects, right? Is there a special certification process already in place, or is still you just say like, hey, we're still doing recommendations, so no certification needed? Is there any process in place on your side?
I mean, certification in terms of like from the regulatory
yes did the regulatory catch up some kind of specific machine learning thing here, right? Because
so I mean, one thing, since we're working in healthcare, or I mean, all healthcare products need to be certified anyway, like if they include AI or not, right? So this is a point which is sometimes forgotten. So we don't have any AI specific regulations, for every system that we develop and that we market. We need to make sure if it works, and to me, honestly, it doesn't make too much of a difference what technology we use inside, right? We always need to test, we always need to validate, but of course there are certain, I would say, good recommendations, of how you can develop robust AI applications, or let's say the other way around, there are certain pitfalls, of what you should not do, because it can backfire later on. And from what I've heard, the regulatory offices, they are pretty quick at learning, nowadays. So they ask if you have machine learning in your product. They now ask specifically, for example, for what kind of data you use to train and to validate, right? Do you really cover the complete population that you want the system to work on, etc.? So I wouldn't call it specific AI regulations, but it's AI specific questions for sure. There are, I would say.
Right. So Tobias, you've already been on different stops and had an adventurous journey in academia and now also in the economy. So which would you say was the greatest lesson that you've learned in the past and that you maybe would like to share with the audience?
Good question. I think, like, following up also the last couple of questions, one at least of the great lessons, that I have learned over time and that has come back like a number of times, is that do not trust preliminary results, with things that you are doing. I mean, it's always, you always have the temptation, of course, if you have some nice results, to directly write the abstract and send it in, of course it will work, I'm always optimistic, so I think, for sure, even with more data, it will work, we can validate it. But it turns out it's not always the case, right? So I think it's worth taking the time to really collect like representative data, to really do a thorough validation before, I don't know, maybe submitting your abstract to a conference or presenting results somewhere, right? Because as I said, the temptation is there, especially with the acceleration of the field. Everybody is producing results day and night, and you you don't want to be left behind, so to speak. But take the time and validate and be critical, about your own results. I think this always pays off in the end.
Yeah, that's good advice for sure. So if we look to the future, for example, 5 years from now, who would you trust more? Would you trust more a healthcare professional who is relying on a semi-automated machine learning support system, or rather an expert relying on his or her own expertise and experience?
So ideally, I would trust an expert with the support of an AI system, honestly. because I think that's the optimum really what you can reach. I think AI systems are important and will become more important. Yeah, for example, I'm going to this skin cancer screening, for example, right? And there, the physician, she has a software, yeah, attached to a camera, and of course, she's also looking like at everything, yeah. But she does the photo with the camera, she sends it to the software, and the software also gives like a quantitative, objective evaluation of that. And to me, that is increasing my trust actually, yeah, because I trust the physician. I think she has a lot of expertise and is probably an expert, but having that software running at the same time, it's like having a second expert there. So to me, if I have the choice, I would always go for both.
Yeah. Yeah, probably that's like reassuring and making it even more clear
Exactly.
that the perspective of the expert is probably the right. So, Tobias, we are almost at the very end of our session. So, at every end of the episode, we play a game. It's called Authentic Autocomplete. So, let me give you for the closing a couple of sentence starters, and you just finish. So, Siemens is
much more digital than you would think for a metal industry corporation.
Right. AI is
a fascinating field to work in.
Amazing. Forchheim and Princeton connects.
10G broadband connection.
Good answer.
Cheeky answer.
Corona has taught me
how quickly established habits and systems can change. Yeah.
Beautiful. And last but not least, my personal superpower is
I can prepare a presentation in less than 1 hour. That has been helpful a lot of times in the past.
No. That helps in the corporate, in a corporate level, but I'm not sure whether this is a great competence for a cool geek, right? Yeah, but fair enough.
It's always important to explain. Important to explain.
Sure, right. That's actually pretty right. Tobias, thanks so much for being such accessible, such honest, such bold, such open, and for obviously being you and spending this valuable time with us straight after your vacation and directly at the first day again. We really loved it. I think this can't be right, Aubrey. This can't be the last session on on the focus on precision medicine and impact of machine learning in healthcare. So I really enjoyed it. Really enjoyed it. Thanks so much.
It has been a pleasure. Yeah, it was good fun. Thanks a lot for inviting me.
Folks out there, stay tuned. There's obviously a bit more to come, even much more to come. Stay bold, committed, open-minded, and we hear us definitely at the next Siemens AI Lab podcast. Cheers.